Welcome to this predicted paper from onmaths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing. Enjoy! So we can draw out our place value grid to help us out with this question. We've got thousands, hundreds, tens and units. So we'll need another one there. So thousands go here, hundreds here, tens here, and then units here. So this says 2000, so a 2 will go in the thousands column. 30, so that'll be a 3 there, and 2. So we need to fill in a 0 here to keep that 2 as 2000, otherwise that would collapse and it would become 232. So the answer is 2032. So this person's at Ashcook at 2017. So they're going to have missed this train here, and they're going to have missed this train here. So those are off. But they will be in time for this train here. And we're looking for the time it hits rise down. So it will get to flute at 2052, and then rise down will be at 2124. So with this question, we need to first of all count how many sides this polygon has. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's 10 sides. And we just need to know that a 10-sided shape is a decagon. Now we are expected to know all of the names of shapes between 3 and 10 sides. So if you don't know them already, just sit down and learn them. For us to create the largest number, we need to pick the biggest digits for the start of the number. So the biggest digit is 7, then 6, then 4, then 3. But the question says it wants the largest even number, so we need to just swap the last 2 around to make sure that it is even. So our answer is 7,634. All of this here basically means that t, the time, is between 120 and 130. If it is 120, then it's in this group. If it is exactly 130, it's actually in the next group. So we're going to look at all the numbers that are between 120 and 130. So we've got 1, 2, 3, 4. And so the frequency will be 4. The next group is all the numbers between 130 and 140, which is just this one here. Then we have between 140 and 150, which is just this one here. And then we have between 150 and 160. That will be these two here. Whenever we multiply two negatives, we always get a positive, so we know our answer will be positive. We're going to do 9 times 12, which is going to be 108, and v times v, which is going to be v squared. So the way these tables work is if you're looking for distance between Chauvin and Grill, you find out where the two of those overlap, and so they overlap at the 41. So you go down from Chauvin, left from Grill, and we get 41. And so it would be 41 miles between them. Congruent means that it's a shape that is exactly the same as another shape, but it can be rotated, translated, can be flipped around, but it's basically the same shape. So I imagine cutting it out onto cardboard and trying to fit it into the other shape. If it can fit, then they are congruent. So looking at the shapes, we've got some triangles, we've got some weird looking shapes, but I'm going to look at A and I'm going to draw A in. So I'm just going to trace A, and what we can notice is if I manipulate that now and if I bring it down to E, it kind of almost looks the same as E, But what I can do is actually just reflect it, and it's exactly the same as E. So A and E are congruent. So we're going to start off by working out what 100% of 120 is. Well, that's obviously just going to be 120. And we're trying to get to 6%. So we always start off by working out 10%. It's always normally useful. And we just divide that 120 by 10, so we get 12. And we try to get 6%, so it'd be nice if I knew 5%. And 5% is nice and easy because we just halve that 10%. So that'd be 6. And if we got the 1% as well, we can get to the 6%. So to find out what 1% is, we just divide the 10% by 10 and get 1.2. So to get the 6%, we're going to add the 5% and the 1%. So we're going to add the 6 and the 1.2. And so we just do 6 plus 1.2, which is just going to be 7.2. And that's our answer. So 55% is the same as 55 over 100. And what I can do is I can divide top of the fraction by 5. And so that is going to equal 11 over 20. Now in total there are 20 squares here because there's 5 across and 4 down. 5 times 4 is 20. And if there's 20 squares and we're looking to shade in 11 20ths, it's just going to be 11 squares. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the first thing we're going to do is write this as a ratio between the fractions. So we're going to have green to black. Now it says that a quarter of the counters are black, and therefore the remaining counters will be green. So if a quarter are black, that leaves 3/4 to be green. And what we can do here is on both sides of the ratio, what I'm going to do is just times it by 4. So I'm just going to times 4 both sides. So 3 divided by 4 times 4, because over 4 just means divided by 4. So 3 divided by 4 times by 4 just gets rid of the fraction. And 1 divided by 4 times 4 is just going to be 1. Now this might surprise some people because they will probably think it's a ratio of 4 to 1. But we can show here that it's a ratio of 3 to 1. If we write in how many sides each shape has, triangle has 3, quadrilateral 4, pentagon 5, hexagon 6, you'll notice the number of vertices is twice the amount of each of them. So if a shape has 15 sides, we just times that by 2 and it will have 30 vertices. So we're going to track the amount of eggs needed to make a certain amount of cupcakes. So we're given in the question that it's 6 cupcakes requires 4 eggs, and what we're going to do is we're just going to work out how many eggs is required for 1 cupcake. So we're going to divide both sides by 6, and that's for 1 cupcake will be 2/3 of an egg, and we're looking to make 18 cupcakes, so I'm going to times that by 18 on both sides. So for 18 cupcakes, 2/3 times 18 is going to be 12 eggs. So we're going to require 12 eggs. Something else we could have done to go straight there is just times the amount of cupcakes by 3 and times the amount of eggs by 3. With these questions, we've just got to go around and fill in what we can. And there's going to be some numbers like this one here we can't fill in yet, so we're going to have to be strategic in the order we do it. I'm going to first of all look here and notice that the total of girls and boys is 29, the total of the boys is 18, so take away the 18 from 29 and we get 11. Next one I'm going to fill out is this one. Notice that the total for the green is 15, total for the boys who's picked green is 12, and therefore for the girls it's going to be 3. Then looking around, what's the next thing that we can fill out? We can fill out this one, because the total for the boys is 18, green is 12, blue is 1, therefore we've got 5 left over. Then we can fill out this one, 2 plus 5 is 7. Then we can fill out this one, so 2 plus 3 is 5, then plus another 6 would be 11, and then 6 plus 1 is 7. So we need to rewrite this fact here so that it looks like this. So I'm just going to focus on this fact, and what I'm going to do is divide 99 both sides. So we end up with 24 equals 2,376 divided by 99. Now you can see that that looks like that, which is kind of the point. So I'm just going to swap that around. So 2,376 divided by 99 equals 24. And I'm going to write this underneath so we can see the similarity. So 2,376,000 divided by 99,000 equals. Okay, let's have a look at what's happening between these two numbers. So this part here is multiplied by 1,000, and this part here is multiplied by 100. So what effect is the fact that the first numbers multiplied by 1,000 going to have on our answer? Well, it's obviously going to make it 1,000 times bigger. So it will make it 24,000, won't it? 2, 3. So that's that bit done. But what effect will multiplying the denominator have by 100 on our answer? Okay, so if you think about a half, if we times the bottom by 100, it becomes 1 over 200. Now, what is this compared to that? What is 1 over 200 compared to 1/2? Well, it's 100 times smaller. So when you're doing stuff to the denominator, you're actually making it smaller. So this times 100 is making our answer 100 times smaller. So we just knock off 2 of the zeros. We divide it by 100. So our answer will be 240. So the only options for the next card are for them to be higher, lower, or equal to 12. We already know that the probability for it being higher is 19% and lower is 28%, and all probabilities have to add up to 1, or in this case, because it's percentages, 100%. So to work out the probability that is missing, we're going to take away the 19% and the 28% away from 100% to see what's left, and that's 53%. So 100% of 120 is 120. And let's put that in a bubble. So we're going to split that bubble up to find out what 10% is. And to find 10%, all we need to do is divide it by 10. So divide 120 by 10, you get 12. And then we want to split that bubble up again into 5%. And 5% is found just by halving it again. And so that would be, or just halving it, so that would be half of 12, which is 6. We could do with 1% as well. And we're trying to get to 26%, so we'll do 1%. So dividing the 10% by 10 again, 1.2. And we could do with 20%, and 20% just means we're going to double the 10%. So double 12 will be 24. So to work out 26%, we need to add these together to get to 26. So we're going to add these numbers here together. Okay, so we've got a 6, a 1.2, and a 24. And we're adding them together. And that would be 11, so carry the 1, that would be 3. Now, it says to decrease it by 26%. So 26% is 31.2, so we need to subtract that. So we're going to do 120, take away 31.2. 0.2. So I need to borrow 1 from the 2 to make that a 10, borrow 1 there to make that a 10, and that would be a 9. So 10 take away 2 is 8. 9 take away 1 is 8. And there's a 1 here, so we need to borrow that 1. That's 11 take away 3, which is 8. So our answer is 88.8. A side elevation is the view you'd get if you were standing at the side of a shape. So I'm standing here, and it's the view I'll get. Well, it would be this trapezium here. And to know which side is the side and which one's the front, well, the front is always going to be labelled. They do normally label the sides as well for you. So we're going to draw this trapezium. So the top bit is 3, then it's 6, then it's 8. So I'm just going to start off with the bottom, actually. That might be easier. And draw the 8 across. 1, 2, 3, 4, 5, 6, 7, 8. Then I'm going to do the 6 up. 1, 2, 3, 4, 5, 6. Looks like I left just enough room. Then I'm going to do the 3 across. 1, 2, 3. And then all I need to do is just join up the start and the finish to complete the trapezium. To compare fractions, we must have the denominators to be the same number. So we're going to look at the 6, 2 and 4 times table. We're going to try and find a number that's in all the times table. So I'm just going to write out a few numbers in each times table. And we already see a common one there, which is 12. And actually 12 is in all the times tables. And you can see 4 is in 2 of the times tables, 6 is in 2, but only 12 is in all of them. So we're going to convert these so that they're all over 12. And what I'm going to do is times the top and bottom by 2 for this first one, which will be 10 over 12. Then I'm going to multiply the top and bottom by 6 in the second one, which will give us 6 over 12. And then finally we're going to times top and bottom by 3 for this last fraction, which gives us 9 over 12. And it wants it in ascending order, so we're looking for the smallest fraction first, which is this one. And writing the original fraction as an answer. And then the next one will be this one, because if you look at the numerators, 6, then 9, which will be 3/4. And then 10 is our biggest one, so that would be 5 over 6. A sample space diagram is basically a diagram that shows all the outcomes. And we've got the outcomes from spinner 2 at the top, so either 1, 2 or 3. And we've got the outcomes from spinner 1 down the side, so A, B, C, D or E. And we're just writing down all the combinations. So this will be A2, A3, and then this will be B1, C1, D1, E1, and this will be B2, C2, D2, E2, and this will be B3, C3, D3, and E3. And this represents all the possible outcomes you can get from both spinners. So we've got to first of all work out how many parts there are altogether. So we're told that the ratio of red, yellow and green is 3 to 2 to 4. So to work out how many parts there are altogether, we do 3 plus 2 plus 4, which is 9 parts. So there's 9 equal piles of sweets. Okay, but to work out what one part or one pile of sweets is worth, we're going to get the 99 sweets and divide it by the amount of piles, and that's going to be 11. So one part is worth 11 sweets. We're asked to find out how many yellow sweets, and yellow is the middle one, so it's going to be the 2. So yellow has 2 piles of 11 sweets. 2 times 11 is going to be 22, so it's going to be 22 sweets. So we've got to first of all find out what the gradient is for our graph. So we're just going to pick 2 points and draw a triangle between them. So I'm just going to pick this point here and this point here, and there's no reason I picked those, just pick those at random. And we look at how far it's going to cross, so it's gone across 10, how far it's gone up, so it's gone from 24 to 36, so it's gone 12 up. And to work out the gradient, which you can call n, or you can just write out the word gradient, it's change in y over change in x. So how much has y changed over how much has x changed. So y is this one here, so it's changed by 12, and x has changed by 10. So it's 12 divided by 10, which is 1.2. Now a gradient represents the amount of change in the y per one change in the x. So for every 1 mile we travel, we're going to go up, it's going to cost 1.2 more. So the interpretation that we give for this context, because this is about taxis, is that the taxi will cost £1.20 or 120 pence per 1 unit on the x per mile. And that's true for the gradient for any context. It's for every one of this, how much of this increases, how much the y increases by. So we can see that the first 4 of these have already been plotted. Now it's really important that you you do the coordinate the right way around. So the first one is number and then algebra. So we're looking at this coordinate here. We're 18 on number, which would be here, and then 14 on algebra, which would be this point here. 12 on both, so 12 and 12 would be here, and then 21 and 17. So 21 and 17 would be roughly there. So whenever we have a scatter graph, chances are we'll be drawing a line of best fit. And so that's what we'll start off with, draw a line of best fit in. And it says we're looking for a height of the box, or an estimate of the height of the box with the width of 17. So 17 is here. So the width of 17 will be a line across, let's try and get this just right, line across there. And what we do is we draw a line down when it hits the line of best fit. Now looking at the scale here, this seems to be going up in 2s, and so this line here would be at 3. To find the surface area of the cuboid, I'm just going to label the faces and do them individually. So we've got A, which is 24 by 13. So we're going to do 24 times 13, which is 312. Next we're going to do B, which is this one at the top. And it's 24 across and 8 is the length. So 24 times 8, which is 192. And finally C on this side here, which is going to be 13 times 8, which is 104. Now notice that the faces all have the exact same face on the opposite side. So this one at the back is also A, this one at the side is also C, and the one at the bottom is also B. So what I'm going to do is add up all the areas of the squares and double it. So to work out the surface area, we're going to do 2 times and then 312 plus 192 plus 104, and that will give me 1,216 centimeters cubed squared, because it's an area. So we're asked to reflect this shape along the line y equals x, and y equals x is a diagonal line where all the x values are equal to the y values. So at the bottom here we've got x is 10 and y is 10, so that coordinate would be 10, 10. And then obviously this coordinate 4, 4, etc. So we need to reflect it across this line. And so if I pick a point, I'm going to pick the top one. We can see it goes 4 diagonals to hit that line. So 1, 2, 3, 4. So it will go another 4 diagonals. So that will be one of the coordinates there. And I'm going to do the same with the bottom one. So 1, 2, 3, 4, 5, 6 diagonals. 1, 2, 3, 4, 5, 6 diagonals. So it will be there. And then finally, I'm going to do this slightly harder one. So we've got 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Kind of goes over the other one. ends up here. So if we join these up, and we need to label it B. To find the pressure, we need the area and the force. And we're given the force in the question, and so all we need to do is find out what the area is, which will be the 7 times the 9, which will be 63 centimeters squared. And the force is given to us in the question, so what we can do is write down the pressure formula, which says that pressure equals the force divided by the area. Force is given to us as 2268. The area we've calculated is 63. Divide the 2 and you get 36. So it's going to be 36 newtons per centimetre squared. So this question is asking us really to divide the 5 3/4 by 1 3/4. So we're going to do 5 3/4 divided by 1 3/4, because we're finding out how many of each of these towels, which is 1 3/4 metre, can be made when the total amount of cotton is 5 3/4. So first thing we're going to do is convert them to mixed numbers, to top-heavy or improper fractions, because at the moment they're mixed numbers and we can't divide or times if they're mixed. So we times the 5 by the 4 and add it to the top, which will be 20, and then add it to the top 23, and then do the same. 1 times 4 is 4, plus it to the top is 7/4. Now a little trick here is KFC. We keep the first fraction, we flip the second fraction, and we change the divide sign to a time sign. So we're going to keep this first fraction as it is, change that divide to a times, and flip the second fraction. Okay, whenever we multiply, we just multiply the tops, so 23 times 4, which is 92, and we times the bottoms, which will be 28. And now we need to convert this back into a mixed number. So first of all, actually we can simplify this, because we can divide top and bottom by 4, so that would be 23/7, and then make this a mixed number. So 7's into 23 go 3 whole ones, and then obviously 2 remainders, so it's 2/7. Now it asks us for the amount of towels that she can sew patterns into. Now the issue here is that she will do 3 whole towels, but then have some left over, but she doesn't have enough to create a 4th towel, so it's just going to be 3 as an answer. The first thing to notice is that the tree must be closer to CD than AB. So if we draw a line across the middle, it can't be in the top bit, because that would be closer to line AB. The second piece of information that is given to us is it must be at least 11 meters away from point C. So we get our compass out and measure 11 centimeters, or whatever the scale we're using in this diagram is, and we draw a quarter circle from C. And it says shade the region that it can be planted. So this is the region that represents closer to line CD than AB, but also not within 11 meters of point C. So factorise means to put it into a bracket, and it looks like it's a quadratic here, but it's actually just a linear factorising, because we don't have a number term. So we're going to just use one bracket for this. And looking at these terms, I'm going to focus first on the numbers. So 20 and 30, I can divide both of those by 10, and that will leave 2 and 3. So that's the numbers done. Next, I'm looking at the t terms. So we've got t squared there and a t there. So we can divide out a t, but that will leave a t on the first term. And finally, I'm going to look at the u. and there's just a u on both of them. I can factorise out, and actually that just leaves nothing on the inside of the bracket. Now, always when you do this, expand the bracket to check if you've made any mistakes. So I'm going to do smiles and rainbows. There's loads of different methods. So 10 times 2 is 20, t times t is t squared, and then the u, plus 10 times 3 is 30, times t times u. So we know we've got the right answer. So our answer is 10tu brackets 2t plus 3. This looks like it's a really tricky question, and it is a little bit tricky, but it's a little bit easier than maybe it looks. The highest common factor is found when you have the prime factors, which we do, of two numbers, and you put them into a Venn diagram. Then you can find the prime factor, the highest common factor, by multiplying all the numbers in the overlap. So we're going to rewrite these numbers. Just instead of squared, we're just going to write them out without index form. Just makes it a bit easier. And so I'm just removing the squares, and we're going to draw ourselves a Venn diagram. So let's just do a rectangle at the outside. I'm going to try and do some nice circles here. Try my best anyway. Okay, so on the left hand side we have the 450, on the right hand side we have the 132. So we'll start with the 450 and the numbers. So actually looking at the numbers, looking at the factors at the top, the prime factors, we can see they both have a 2 in them. So I cross them both out and put 2 in the middle. We can see they both have a 3 in them. So cross those 3's out and put a 3 in the middle. And then 450 has a 3, a 5 and a 5. And 132 has the 2 and the 11. So to find the highest common factor, as I said, you multiply all the numbers that are in the middle. And so the highest common factor will be 6. So we're going to start just by writing this out. So m equals 7 brackets x minus 10. And we're going to put our solving lines in. I'm going to start by expanding the brackets, and we don't need to. We could divide both sides by 7, but I think this is a bit easier. And we're going to subtract, or we're going to add 70 to both sides. So we're trying to get x as the subject. So we're trying to get x on its own, and we're next going to divide both sides by 7. So we have m plus 70. All of that over 7 equals x. So x equals m plus 70 over 7. So in this question, we basically need to add the 2 3/4 and the 2 2/5. So we're going to do 2 3/4 plus 2 2/5. Now, if I just rewrite this, 2 3/4 can be written as 2 plus 3/4 plus 2 plus 2 1/5. Or 2/5. So we can add the 2 2's together to make 4, and then all we need to do is add the 3/4 and the 2/5. So when you add two numbers with different denominators, what we need to do is get the common denominators, and we do that by just quickly writing out the 4 and the 5 times table and seeing what the first number in both their times tables is. 16, 20. And 5, 10, 15, 20. So that's 20. So we need to get the bottoms of the fractions to 20. Now for 3/4, to get the bottom to equal 20, we need to times the 4 by 5. And whatever you do to the bottom, you've got to do to the top. So times that by 5 as well, which will be 15. And for 2/5, we'll get that bottom to 20, so we times that by 4, and so we've got to times the top by 4 as well to make it 8. So it's going to be 15 over 20 plus 8 over 20. So we need to add the numerators. So it'd be 15 plus 8, which is going to be 23 over 20. Now that is a top-heavy fraction, so we can rewrite that as 1 and 3/20. And we can add the 4 and the 1 together to make 5 and 3/20. So the answer is 5 and 3/20. So when you read this question, the question's basically asking you to find the bearing of O from B. So the lifeboat is at B, so I'm going to draw a north line here. And to find a bearing, you start from the north line and you keep going clockwise. So we're going to look for this angle here. Now, this angle, which is given to us in the question, and this angle here, which I'm just going to call x, are going to be equal. So x is going to equal 135 degrees. And the reason for that is we've basically got, and I'm just going to draw or extend the north line down, because we've basically got we have a set of parallel lines here, and we have a set of z angles, which we know is alternate angles. So the reason for that is it's alternate angles. And always show the reasons to the examiner. Okay, and so to find out what the bearing is, so the bearing of O from B, it's just going to be 360 take away 135. And the reason for that is angles on a point. We've run out of space. Okay, so we're going to do 360 take away 135, which is 225. And so our answer is 225. When finding a sample of people, you want everyone in the population to have an equal chance of being picked. So in method 1, the fact in a lifestyle magazine might bias the people reading it, because there's groups of people that don't read lifestyle magazines. A poster up in the gym, again, there's groups of people who don't go to the gym. And midday in town centres, well, it might be on a school day, or it might be that you are skewing your data towards retired people. There's lots of reasons why a certain group of people won't be at a town centre at midday. The only one here that gives everyone an equal chance of being picked is this one here. Okay, so picking people randomly from the electoral roll. There are some groups of people who might choose not to be on the electoral roll, but looking at the 4 methods, this one is by far the most fair sample. So we're going to start off with x equals 0, and we're going to write out this equation, but with 0 every time it says x. So it's going to be y equals 0 squared minus 0 plus 10. Well, 0 squared is just 0, so 0 take away 0 is just 0, plus 10 is just going to be 10. So the answer there would be 10. Do the same for 1. So it would be 1 squared minus 1 plus 10. Well, 1 squared is 1, 1 take away 1 is 0, plus 10 is 10. So that will also be 10. 2 squared minus 2 plus 10. 2 squared is 4, 4 take away 2 is 2, plus 10 will be 12. Now we're going to do the negative, so we're going to look at minus 1. So it's y equals minus 1 squared, and it's going to be minus 1 plus 10. So a little bit more complicated here. Minus 1 squared is just 1. Now here you have 2 negatives together. When you have 2 negatives together, it makes a plus. So we've got 1 plus 1 plus 10, which is going to be 12. And then we'll do the minus 2, so it'd be minus 2 squared minus 2 plus 10. So minus 2 squared is 4. The 2 minuses here make a plus, so it'd be plus 2, which would be 6, plus 10 will be 16. So we're going to plot these on our graph. And so we've got minus 2 is at 16, so that'll be there. Minus 1 is at 12, which will be here. 0 is at 10. 1 is at 10, and 2 is at 12. Okay, when you join this up, things to be aware of is you need to make sure that you have a round U at the bottom and not a flat bottom. Okay, so you want to avoid a flat bottom. You also want to make sure that you avoid feathering like that. You want just one nice smooth line. And my recommendation is always to turn the page on its side. I don't have that luxury, so I'm going to try my best with this. But you need to make sure it goes through all the points. And here's the part here where it goes beneath those 2 points. So make sure it goes beneath those 2 points. On most exams, I see them, basically what they do is they draw a line across from those 2 points and say that the line needs to go beneath that, or your curve needs to go beneath that line. So they're looking out that you've gone beneath the line. We're going to start by looking at the numerator and the denominator separately. So looking at the numerator first, we've got 9 to the power of 16 times 9 to the power of 46. Now, when you have two powers of the same base, so they're both 9, base 9, but base is the big number, then what you can do is you can add the indices. So we're going to do 16 plus 46, which is 62. So it's 9 to the power of 62. And looking at the denominator, well, you've got a power inside and outside the bracket. Whenever you have that, you can just multiply them. So it'd be 9 to the power of 40. Now, whenever you've got a division between two powers of the same base, which we have here, it's 9 to the power of 62 divided by 9 to the power of 40, we just take away the indices. So it'd be 62, take away 40, which will be 9 to the power of 22. So our answer is 9 to the power of 22. To prove triangle congruence, you're going to have one of four answers. You're either going to have RHS, SSS, angle, angle, side, or angle, side, angle, and the last one, side, angle, side. So those are our options. So we've got to figure out what we have in this question. Well, we have a right angle, so an angle or right angle. We've got a side, which is actually the hypotenuse, because we know the hypotenuse is opposite the right angle. And then we just have another side. Now, it's not going to be SSS because we don't have three sides. We do have a side and an angle and a side, but the two sides are not next to the angle, so it's not going to be that one. And we don't have two angles, so it's not going to be this one. So the last one is RHS, which is right angle, which we have, hypotenuse, which we have, and side. I'm just going to write the question out, so we've got a little bit bigger writing to play with here. And it doesn't actually matter which method you expand these brackets with. I'm going to use Smiles and Rainbows. So we multiply the 8 by the 10x, which will make 80x, and multiply the 8 by the 4, which will make 32. Now here we've got a minus 5 on the outside. So we do minus 5 times 8x, which is minus 40x. And minus 5 times minus 4, which is actually plus 20. And a lot of students will write take away 20 there, but that is a minus 5 on the outside of the brackets there. So it's minus 5 times the minus 4 there will give you a plus 20. Then 80x take away 40x, which will give us 40x. And 32 plus 20, which would be 52. So our answer would be 40x plus 52. So I'm going to write out the equation again just to give us a bit more space. And the rule we have here is if we have an x on both sides, which we do in here, we pick the smallest one to get rid of. So we've got a 12x and a 7x. And so the smaller number, or the smaller x, would be the 7x. So we're going to get rid of that first. So we've got our lines in, and we're going to take away 7x both sides. And so 12x take away 7x is 5x. And the 7x is gone, so it's just equals to 46. Then we've got the minus 4 to get rid of, so we're going to add 4 both sides. And then we've got this times 5 here, so we're going to divide 5 both sides. So we've got x equals 50 divided by 5, which is 10. When something is cubed, you times it by itself 3 times, so we're going to do the same here. So we've got 5x to the power of minus 6 times 5x to the power of minus 6 times 5x to the power of 6. We're going to put the 5's together, so 5 times 5 times 5, and the x to the power of minus 6's together. Five times 5 times 5 is 125. Now when you times powers with the same base, which we have here because they're all x to the power of minus 6, you add the powers together. So minus 6 plus minus 6 plus minus 6, which is going to be minus 18. Something else we could have done is we could have done 5 to the power of the 3 here, 125, and then done minus 6 times the 3, which would have given us minus 18. The key to estimating is that normally you will be rounding numbers to one significant figure and then working out the answer. So I'm just going to rewrite this fraction here, but instead of 93, we're going to round that to one significant figure, so that will be 90. We're going to round the 265 to one significant figure. Now, some people will write 270, but one significant figure means the line goes after the 2, and so that would round to 300. Then 31 will round to 30, and 97 will round to 100. Now the next step is to see things that we can cancel here. So we can divide top and bottom by 10 to make that a 9 and make that a 3. We can divide top and bottom by 100, make that a 3, make that 1. And we can divide top and bottom by 3, so that will make that 1, and that will make that 1. And so at the top we've got 9 times 1, which is 9, and at the bottom we've got 1 times 1, so 9 divided by 1 is just 9, so our answer will be 9. So here we're asked to factorise a quadratic, and we know it's a quadratic because it's got an x squared term, an x term and a number term. And what we're going to do is we're going to be, first of all, putting two sets of brackets down with an x at the start of each, and what we're trying to find is what number goes here and what number goes here. So we're going to start by looking at this minus 45, and it's a special number because we're looking for two numbers that multiply together to make that minus 45. We're also going to look at this plus 12 here because we're looking for two numbers that add together to make that 12. So what we can do is write out the factors of minus 45, and so that's going to be minus 1 and 45, minus 3 and 15, minus 5 and 9, and then the same but the other way around. So 1 and minus 45, 3 and minus 15, and 5 and minus 9. Remember, we're looking for them to add together to make 12. So we look down the list here, which ones add together to make 12. This one here, minus 3 plus 15 is 12. So our answers will be minus 3 and plus 15, or the other way around. So with each of these pools, try and imagine it being filled. So pool A, first of all, we've got water coming into it, and it's actually going to go quite quickly initially, and then it will hit a point at the end where actually it will go really quite slowly because it's a wider pool. So we would imagine that the graph for pool A would actually go quite quickly at the start, and then at the end it would go much slower. And that doesn't really describe, the graph, the red graph doesn't really describe that at all. So for pool B, we start off actually quite quickly because it's quite thin, and then we have a wider bit here, so it will go slower here, and then we go quickly again. So we need a graph that starts off quite quickly, then goes slowly, and then goes quickly. And the steeper the graph on our depth time graph, the faster it's filling up, and that red line doesn't really describe that either. Pool C, however, we can see it goes slowly at the start, and then because it's thin it will go quicker, so nice quickly, and then it will go slowly again. Well, that is a perfect description of the graph that we're given. So the graph we're given is definitely going to be for pool C. We know that when you multiply powers with the same base, and here we've got all these as base V, you add the powers. So we're actually looking at what do we add to 11, which is this one here, to get to the 15. 11 plus 4 is 15. So W therefore equals 4. So it's really important, first of all, we make clear about how we convert things. So if I've got a unit in kilometers and I want to convert it into meters, then we know we just times it by 1,000. So 2 kilometers is 2,000 meters. But if I have something in kilometers squared and I want to convert it into meters squared, I actually times it by 1,000 squared, which is 1,000 times 1,000. Okay, so I'm actually timesing it by not 1,000, but 1,000 squared. So that's another 3 zeros. You can see here that that's 1,000,000. So we times it by 1,000,000. So 13 kilometers squared is going to be the 13, and then it's going to be times by 1,000,000. So 1, 2, 3, 1, 2, 3. So it's going to be 13 million. Now, it says here the farmer must pay 1 pence tax for every metre squared. So this is going to be 13 million metres squared. And so that's going to cost him or her 13 million pence. But the answer is going to be in pounds. So we just need to get rid of 2 of the zeros at the end. So it's going to be 13, 1, 2, 3, 4. So it's going to be £130,000. So angles on a point add up to 360, and we are given the values of the angles, but in terms of r. So we know that r plus 9r plus 20 will equal 360. So we've got an equation here we can solve. So first of all, let's add the r's together, and so that will be 10r plus 20 equals 360. Then we're going to subtract the 20 from both sides. So we have 10r equals 340. And then we're going to divide by 10 both sides. So we have r equals 34. So our answer is 34. So the symbol here basically means and. And the way I remember it is if you draw that symbol and just put a line through it, you can make the word and. So we're looking at the probability of getting something that is in A and C. So the only ones that are in A and C are this 8 and this 9 here. So we're going to just add the 8 and the 9 together, which give us 17. Now we need to then work out how many numbers there are in total, so that's all of them. So 4 plus 8 plus 9 plus 5 plus 8 plus 3 plus 11 plus 6. So we need the total, which is 54. And then we get the 17, and we put that over the amount in total, so over 54. So we're going to first of all look at the starting section. So we've got the probability of a blue being picked from bag 1 is 7 over 11. So the probability for blue and red must equal 1. So what do we add to 7 to get to 11? Well, we add 4, and so it would be 4 over 11. So these two here must add up to 11 over 11, which is 1. Looking at the next section, we've got 11 over 15 chance of picking a blue. So what's the probability of picking a red? Again, 11 over 15 plus the probability of a red must equal 1. So that's going to be 4 over 15. 4 over 15 plus 11 over 15 is 1. And we've got the final section down here. Now, this final section, we haven't got any fractions for, but bag 2 is independent to bag 1. So bag 2 is just sitting there ready to be picked after we pick bag 1. So the probability is going to be exactly the same as the ones at the top. I'm going to do just a quick multiplication grid. And what I'm going to do is I'm going to put the 2x plus 3 at the top, so 2x and then plus 3, and then 3x minus 11 down the side. Multiply them out, 3 times 2 is 6, so that'd be 6x squared, 3 times 3 is 9, so that'd be 9x. Minus 11 times positive 2 will be minus 22x, and then minus 11 times positive 3 will be minus 33. Get them all together, so we've got 6x squared plus 9x, because that is a positive, minus 22x minus 33. And we can see here that the plus 9x and the minus 22x are like terms, so we can add them together to make minus 13x, and that's our answer. So our answer is 6x squared minus 13x minus 33. First thing we notice is that there is a square here, so we can work out what this length is going to be. It's also going to be 40 centimeters. And whenever we're working out the area of a shaded area, we're normally working out the area of two shapes and subtracting one from the other. And this question's really no different. So we're going to start off working out the area of the square. And all we need to do now for that is 40 times 40, which will be 1,600 centimeters squared. I normally only put units in our answer. The next thing we're going to do is work out the area of the circle, but to do that we need to work out what the diameter of the circle is, and if you notice that the diameter of the circle is just 40 degrees. It's the same as the width of the square, or height of the square. So if the diameter is 40 degrees, the radius would be 20 degrees. So for the circle, for the area of the circle, we're going to do pi times the radius, which is 20 squared, and 20 squared would be 400, so this will be 400 pi. This question's asking us to leave it in terms of pi, so we're going to do that. Now next we're going to work out the all of the corners, so that includes these three here and this one. So I'll say, like, I don't know, 4 corners. Just try and explain to the person marking my exam what I'm doing. And to do that, we're just going to do the square, take away the circle. So 1,600 take away 400 pi. Now we can't actually do anything more than that. That is our answer. So it's just, we just leave it at that. And to work out just the shaded bit, which is this bit here, they are 4 equal amounts that we've got for these corners. So just one corner, which is the shaded bit, will be the 4 corners divided by 4. Now we've got a kind of fraction here. We can divide all of the terms by 4. So that will leave 1 at the bottom, 100 pi here. And this will be 1,600 divided by 4 is 400. So we're just cancelling the fraction, and actually we leave it as 400 minus 100 pi. And that indeed is our answer. You can't simplify that any further. So we've got to first of all understand what standard form is. And standard form is a number that is between 1 and 10, but not including 10, times 10 to the power of another number. So to find out what the number's going to be for our standard form, we're going to just write down the decimal first, so 0.098, and we've got to put a decimal point in somewhere to make this a number between 1 and 10. So if I put it in here, that would make it 9.8, and we're ignoring the zeros to the left hand side. So we know that our standard form is going to start off with 9.8 times 10 to the power of something. Now this times 10 is always going to be there. It's never divided by 10 or anything like that. It's always times 10. Next we've got to find out what the power is going to be. So first of all, if it's a small number, if it's a number less than 1, which this is, it's a small number, it's going to be a negative power. And the next thing we do is work out how many jumps we had to do. So it would be 1, 2 jumps between where the decimal point was and where it is now. So 2 jumps means it's going to be to the power of -2. First thing I'm going to do is add these column vectors. So we're going to add the tops first, and then we're going to add the bottoms. So it's plus minus 14. And so at the top it would be -4, and 11 take away 14 is -3. Then I'm going to pick a point on my shape, and the the top one tells us how far right we're going. So we know we're going 4 to the left because it's obviously a negative. So we're going to go 1, 2, 3, 4. The bottom one tells us how far up we're going. Well, it's going to be down because it's a -3. So 1, 2, 3. And we can do that for each of the other points. So 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3. And when we've done that, we can join them all up with straight lines. And label the new shape B. So here we're given a right angle triangle, and the question involves 2 lengths and angles, so we know we're going to be using trigonometry. So let's start by labeling our sides. The one opposite the right angle is the hypotenuse, the one opposite the marked angle is the opposite, and the one between the right angle and the marked angle is the adjacent. Now notice the hypotenuse doesn't have a number or letter next to it, so let's get rid of that. Next thing we do is draw our trigonometry triangles. So we've got SO, Ca, Toa. Now we've crossed out the H, so we're not going to be interested in the SO or the Ca. So it's going to be Toa. Toa is short for tan the angle equals opposite over adjacent. The angle is 60, so it's tan 60 equals x over 1. And so now here, we're looking for the exact value of x. So if I times both sides here, let's just get our solving lines in here, and times both sides by 1, or just get rid of the fraction, we end up with x equals tan 60. Now you need to know off by heart what tan 60 is, and we can work it out just briefly by drawing a right angle triangle. Sorry, not a right angle triangle, an equilateral triangle. So that is going to be 60 by 60 by 60. And we're going to put all the lengths around the outside as 2. And what I'm going to do is I'm going to cut it down the middle. And I'm just going to cut it into half. And so the length at the bottom will be 1. And using Pythagoras, we've got to work out the length here. It's going to be 2 squared, which is 4, take away 1 squared, which is 1, will be 3, and then square root it would be √3. So we know that's going to be √3. So looking at labeling the sides here, just pick a colour to make sure it's nice. So we've got the hypotenuse here, we've got the adjacent here, and then the √3 will be the opposite. And so we're looking for tan 60. So tan, as we know, is the opposite over adjacent. And so tan 60 is going to be the opposite, which is √3, over the adjacent, which is 1 in our diagram there. So tan 60 is equivalent, it's the same as √3 over 1, or just √3. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.